Somewhere in our galaxy, an invisible monster drifts. A cosmic phantom, silent and unseen, yet possessing a gravitational pull so immense it can warp the very fabric of space and time. It's a rogue black hole. When we think about it, some questions come to mind. Could it find us? Could it break into our solar system? And what would happen if it did? What is a rogue black hole? When we talk about a black hole, a deep void in space might come to mind. But the truth is far more astonishing. A black hole is not a void in the traditional sense. Rather, it's a point in space-time where matter collapses upon itself to be compressed into an infinitesimally small volume, creating an overwhelming gravity from which nothing, not even light, can escape once it crosses the event horizon, the point of no return. Now imagine one of these cosmic objects not orbiting a star, nor bound to a galaxy's center, but wandering alone in dark space. This is the rogue black hole, a cosmic wanderer moving freely through the darkness. Most black holes we know are either supermassive giants, residing at the centers of galaxies, or stellar mass black holes, formed when massive stars collapse, often paired with a companion star. But rogue black holes are different. They are usually stellar mass black holes that have been ejected from their birthplace by violent cosmic events, such as a massive supernova explosion or a violent gravitational encounter with another massive cosmic body. These events give them a powerful push, launching them on an endless journey through space. Observing these black holes directly is almost impossible because they emit no light. The only clues to their existence come from their immense gravity, which can bend the light from distant stars or disturb the motion of objects around them. They are cosmic ghosts, revealing themselves only through their hidden gravitational fingerprints. Signs one is coming. If rogue black holes are invisible, how could we ever know one is approaching us? The answer lies in their gravity. Astronomers cannot see the black holes themselves, but they can observe the effects of their immense pull. The primary tool in this regard is gravitational microlensing. Imagine a distant star shining steadily in the night sky. If a rogue black hole passes between us and that star, its gravity will bend and focus the star's light, causing the star to suddenly brighten and then fade again. This temporary brightening is a clear signature that astronomers monitor using telescopes that track millions of stars simultaneously. Another method is astrometry, measuring the precise positions of stars over years. If a rogue black hole passes near a star, its gravity will tug on the star slightly, causing it to wobble in its path. These shifts are very small, but with precise instruments, they can be detected. There is also a rare but dramatic clue: X-ray flares resulting from a tidal disruption event. If a rogue black hole captures a passing star and tears it apart, the shredded material heats up as it spirals around the black hole, producing a powerful burst of X-rays. It's an extraordinary sight, but it only happens if there's a close encounter between the black hole and another star. We may never see rogue black holes directly, but by following these gravitational breadcrumbs, astronomers can still track the silent wanderers of the universe. All the consequences. First, we must clarify that a black hole is not a giant space vacuum that sucks everything from far away. Its gravity is only dangerous if you get close to it. In fact, if our sun suddenly turned into a black hole of the same mass, Earth's orbit would not change at all. We would only lose sunlight and freeze in the dark. The danger from a rogue black hole comes when it passes nearby. Its immense gravity could disrupt the delicate balance of our solar system. Planets, asteroids, and comets could be thrown into new orbits. Some planets might be ejected into deep space, collide with each other, or spiral towards the sun. For Earth, even a slight shift in orbit could lead to extreme climate swings, scorching heat at one point in the year and deadly cold at another. Or, in the worst case, send us drifting into interstellar space as a frozen world. If Earth passed too close to a black hole, tidal forces would become deadly. The side of Earth closer to the black hole would feel a much stronger pull than the far side, stretching the planet until it tore apart, a process scientists call spaghettification. Even without complete destruction, the stress could cause global earthquakes, massive volcanic eruptions, and the loss of our oceans to space. A rogue black hole could also strip away our atmosphere, leaving Earth bare and lifeless. And if the Sun's own orbit were thrown off, or if the Sun itself were pulled in, we would lose our heat source, and the planet would quickly freeze in an endless night. The risk depends on two things: the black hole's mass and how close it comes. A distant pass might only disturb far-off comets in the Oort cloud, but a close pass, or worse, a direct hit, would be catastrophic for our solar system. Or likelihood. Before you start worrying about a black hole crashing into our neighborhood, here's the good news. The probabilities are extremely low. Space is incredibly vast. For stellar mass rogue black holes, those born from collapsing stars, the chance of one entering our solar system and causing real trouble during its lifetime is practically zero. The Milky Way may contain hundreds of millions of isolated black holes, but the space they wander through is so vast that the odds of one hitting a tiny corner of our universe are like throwing a single grain of sand into the ocean and expecting it to strike another specific grain. There's also the idea of primordial black holes. Hypothetical black holes formed immediately after the Big Bang. Some theories suggest they could be very small, even microscopic, and might make up part of dark matter. If they exist, one might pass through our solar system every decade or so. But unless it was of a rare specific mass and hit something directly, it would likely pass unnoticed. We know from history that close approaches by other stars are rare and usually harmless. About 70,000 years ago, a small binary star system called Schultz's star passed through the outer edge of our solar system, disturbing some comets in the Oort cloud but leaving the planets untouched. It's a reminder that, while cosmic flybys can happen, truly dangerous ones are the exception, not the rule. Final thought. The idea of a rogue black hole drifting through our solar system sounds like a plot from a science fiction movie, but in reality, there's no need to lose sleep over it. Space is vast, and the chances of such a close encounter are so tiny, they're almost zero. Our solar system is stable, and the immense distances between stars act as a natural shield against most cosmic threats. Instead of fear, these hidden wanderers should inspire wonder. They are the silent remnants of massive stars crossing the galaxy unseen, shaped by some of the most extreme laws of physics in nature. They remind us how vast and complex our universe is, and how even the rarest and most elusive objects have their place in its grand design. For now, our small patch of space remains safe, stable, and illuminated by the familiar warmth of the sun. Rogue black holes may drift through the galaxy for millions of years, but your chance to catch our next deep space story could pass you by in seconds. Subscribe now so you're on board for every new discovery. And if this video pulled you in like a gravitational tide, smash that like button. It's the simplest way to support the channel and ensure we keep exploring the cosmos together.